Find the perimeter of the region. Oh, okay. So I want you to notice that. So let's do these just one bit at a time here. I'm going to get this out of here. So the perimeter is going to be the whole distance around. So you go 28 inches, then some circular parts, 6 inches, 28 inches, 6 inches. So you can do 6 plus 6 plus 28 plus 28, which is 68 inches. Those are the flat beds. But then we've also got these parts right here. Now, each one's 90 degrees, and it looks like it is the same length each way. So the radius is going to be 3 inches because it's 6 inches this way, so half of that is 3. So the circumference of one of these circles, if it was a full circle, is 2 times pi times the radius, which is 3, which is 6 pi inches. But of course, it's 90 out of 360, which, by the way, reduces to a fourth, like we said. So it's actually 1/4 times 6 pi. Those reduce. That's 2, 3. So 3/2 pi. Now, that's going to feel a little silly in a second, because how many of those segments are there? 1, 2, 3, 4. So we multiply that by 4, and you actually just get your 6 pi inches back, which makes sense, because that's going to be a full circle that you put together. So the exact perimeter of this figure is 68 plus 6 pi inches, which, again, might not be incredibly helpful depending on what you're trying to accomplish here. So we're going to say it's about 86.85 inches. Well, bam. All right. Find the length of the chain of if the circumference of the rear sprocket and front sprocket are 12 and 20 inches, respectively. So I like this question. So this is 10 inches, and this is 10 inches. So those come together to make 20. But now we have this part here, which is 160 degrees out of 360, which is 1636, which is 8/18, which is 4/9. 4/9 of the circumference of the little sprocket, which had a circumference of 12. How helpful. Multiply that by 12, and that's going to cross divide. That's going to be divided by 4, 3, so 16/3 inches, because they actually told us what the circumference was. And so this one here is 185 degrees. So actually I'm going to do 20 plus 16/3 plus, and there's 185 out of 360, and I'm going to reduce that by 5 because I can't think of anything. 185 divided by 5 is 37, which I'm quite sure is prime, and 360 divided by 5 is 72, gross. 37 seconds of that sprocket is taken up by chain, and it has a 20-inch circumference, but it's 70 seconds of it. Gross. So 37. Well, at least I can kind of reduce that. That's going to be, reduce it by 2, 10, 72 divided by 2 is 36. Reduce it again by 2, 5, and that's going to be 18. So 37/18 inches, which I'm going to go ahead and just add them up and get that as a decimal here. 20 plus 16/3 plus 37/18 inches is 27.38 repeating. Just the 8 repeating inches is the length of the chain. The 20 inches from each of these, the 16/3 of an inch, because that's 160 360ths of that sprocket, and then the 37/18 for that terrible 185 360ths of that sprocket, the big sprocket right there. Okay. So there's another way to measure angles, by the way, not just degrees, and they're called radians. So recall that a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of an arc to 360 degrees. See why I consider the diagram. Oh, we talked about this. A circle of radius 1 has a circumference of 2 pi, so the arc length of CD is measure of arc CD times over 360 times 2 pi. But recall that all circles are similar and that corresponding lengths of similar figures are proportional. Because the measure of arc AB equals the measure of arc CD, AB and CD are corresponding arcs. So you can write the following proportion. The arc length of AB over the arc length of CD is the R over 1, the radius of the big circle over the radius of 1 for the little circle. Then the arc length of arc AB, that means that the arc length of AB is equal to the radius times the arc length of CD. And that also means that the arc length of AB is equal to the radius times 300, whatever the measure of CD is, divided by 360 times 2 pi. This form of the equation shows that the arc length associated with the central angle is proportional to the radius of a circle. The constant proportionality, the measure of CD over 360 degrees times 2 pi is defined to be the radian measure of the central angle associated with the arc. If that didn't make any sense whatsoever, it is totally fine. Here's the deal. Let's say that this angle right here is 80 degrees. So it's 80 degrees on both of these, but the measure of that angle in radians would just be the arc length of this, using this formula up here, 80 360ths, which is 836, which is 1/9, times 2 times pi times r, when the radius is 1, so it would be 2/9 pi. That length there is the radian variant of 80 degrees. 80 degrees is equal to 2/9 pi radians. That's the idea, and we're going to come back to that a little bit later. But for now, if you have any questions, please make sure you send a message to your instructor. This is Mr. P signing off, and I hope you have a wonderful rest of your day.